And let's continue working on long division, everyone's favorite way to divide polynomials. Okay, so we have x cubed minus 2x squared minus 6. Now, note something interesting about this question. We don't have an x term here, right? And what do we do when that's the case for long division? We essentially have to just include a 0x term right here to fill in the gap. Otherwise, long division is essentially going to get really messy and it might not work. We might make a mistake. So whenever you skip a term, right, because we have cubed, we have squared, x cubed, x squared. If we don't have an x, you just put a 0x right there. So, okay, now let's just get started. And our first step is to divide x cubed by x. And we're going to get x squared. And x squared times x is x cubed. X squared times 1 is just x squared. Now we can subtract these things. X cubed minus x cubed is 0. Negative 2x squared minus x squared is negative 3x squared. Because negative 2 minus 1 is negative 3. Then I can bring down the 0x. And what is my next step? Well, negative 3x squared divided by x is just negative 3x. Then I can multiply negative 3x by x and negative 3x by 1. And now we can subtract these guys. So those disappear, and we get 0x minus negative 3x. That's just positive 3x. Because minus a negative number makes it a plus, so 0 plus 3, 3. Hopefully I'm not going too fast. Then I can bring down the minus 6. And my last step will be to divide 3x by x. So I can write a 3 over here for the quotient. And multiply that 3 by x plus 1. So we're going to get 3x plus 3. Because 3 times 1 is 3. Then I will subtract them. 3x minus 3x is 0. Negative 6 minus 3 is negative 9. So I can scratch the 0. The remainder is negative 9. Remainder. Now let's just write the division statement. So we have x cubed minus 2x squared minus 6 equals x plus 1 times x squared minus 3x plus 3, which is the quotient, plus the remainder of negative 9. So we can essentially just subtract 9, because when we add a negative number, that's equivalent to subtracting it. And that's it.